Dear student, today we'll see the new points acids and bases. You know this in an ionic equilibrium, we have to study the charges, then electrolyte, types of electrolyte, and acids and bases. Previous lecture, we have seen the introduction, charges, then the some points, the ionic and unionic molecules. That is the equilibrium, ionic equilibrium is what. Now first, acids and bases. Acids and bases are most familiar to all the chemical compounds. For example, the vinegar that contains the acid, the NaOH, that soap that contains the NaOH, in our digestive juice that contains the 0.1 HCl, then Atomwile's battery that contains the 40% H2SO4. Now these are the number of acids and the bases that already we have to see in everyday life. But we know the acids and bases. What is meant by the acids? According to the old concept or the conceptual definition or experimental definition of acids and the bases. What is that acids and bases? Now first we know the acid. Acids is a substance. Base is also substance. Means acid is a substance. Base is also substance. Whether the ions, molecules, or the atoms. With that, acids is a substance which dissolve in water to produce the hydrogen ions, which produce the OH minus ions. There are the definitions of acids and bases according to the conceptual definition. But before that, what is the experimental definition? What is the operational definition of acids and bases? How to identify the acid? How to identify the base on the basis of some different tests? Acid, which has a sour taste. Acid which has a sour taste, then the acid reacts with the metal to give out the hydrogen ions. Acid or base is the soapy to touch. Base which neutralize the acid. Acid which neutralize the base. That is the acid, sour taste, base, bitter taste. For example, suppose the HCl and the sodium hydroxide. Base, soapy to touch. Base is the bitter taste. Anyway, HCl is the HCl is the acid, but which has the sour taste. That is to identify the acid and the base. Now there is some identification of the acid and the base. But after that, that is not a correct definition to identify the acid and the bases. Then after that, there are some scientists to clear idea about the how to decide the acid and the base. There are the three scientists to define, to explain about the acids and the bases. Now, first one, our first theory, our first scientist, that is to explain the acids and the bases. Now, first theory, that is the Arrhenius theory. Now, this Arrhenius, that is one scientist to define, to explain the acid as well as the base. Then how to define, how to explain, then how to identify which one is the acid and which one is the base. One by one, according to the Arrhenius theory, that is called the water ion concept. Water ion concept. Now, according to the Arrhenius theory, to define the acid and the base, the acid is a substance, whether the molecules, atom or the ions. This acid is a substance which contains a hydrogen and produce the H plus ions. That is the acid. In short, this acid is a substance which can produce the hydrogen ions. That is called the acid according to the base. Then how can define the base according to the Arrhenius theory? Base also defined. The base is also substance which can or which contains the hydroxyl group and produce that ions. Which ions? The hydroxyl ions. And that's why that is called the base. Means according to the Arrhenians, in short, the acid. Now, for example, let us consider the HCl is the one acid which dissolve in water to produce the H plus and the Cl minus ion. That is in aqueous one. Aqueous and the aqueous. Means HCl is a substance which contains the hydrogen, and to produce the H plus means the hydrogen ions, that is called the acid according to the Arrhenius. Now, another example for base. Base is that substance means sodium hydroxide NaOH is that substance which contains the hydrogen OH group, and to produce the Na plus and the OH minus ions, and that is the hydroxyl ions according to the definition of the Arrhenius or base. Therefore, the base is a substance which contains the hydroxyl ions. To produce the hydroxyl ions is nothing but the base according to the Arrhenius concept. Now, another example for acid and base. Acid, that acidic acid means acidic acid CS3COOH that contains the hydrogen. Okay, that contains the hydrogen, and to produce also produce these acetate ions, that is a negative, and the H plus ions. That H plus ion is important because to produce the hydrogen according to the Arrhenius theory. Now, another base, that is ammonium hydroxide. That is ammonium hydroxide also one of the example of that base. Means ammonium hydroxide is a base then that contains these hydroxyl group, OH group, and to produce the NH plus and the hydroxyl ions. And that is the definition of base according to the Arrhenius theory, to decide whether which one is the acid and which one is the base. which substance is acid, which substance is base. Therefore, this is the RDS theory. Another concept to identify, to explain the acid and the base. Another scientist is the Laurie-Bronsted concept. That is also called as the Protonic Concept. Now, in the 1923, there is one scientist, Bronsted and the Laurie. He proposed one theory that is called the Protonic Concept or theory, or Laurie-Bronsted concept theory about the acid and the base. Now, how can define, how can identify, how can explain the acid and base according to that theory? Now, first, the acid. Then, according to the Brown concept or the Laurie concept, the acid also one of the substance which can donate, that is important, donate the proton, denoted by the H plus, proton which denote the H plus to the another substance is known as the acid according to the Laurie and Bronsted concept. In short, the acid is nothing but the proton donor which can donate a proton, that is the acid. And base is which can accept the proton to the another substance is known as the base. Now, for example, suppose that HCl plus NH3 that gives the ammonium plus and Cl minus ions. Now, there are the two substances. One is the acid HCl and second is the base ammonia. And to produce the ammonium ions and the Cl minus ions. Now, here in this example, HCl is an acid. Why this is called the one acid? Because this H, that is one proton. This H which donate the proton to the ammonia, and that's why this HCl is an acid. Another, that ammonia is the base. Why this is called the base? Because this ammonia which accept the one proton from the another substance, and that's why the ammonia is a base. HCl is a acid because which donate a one proton to the another substance, and ammonia is a base to accept the one proton from the another substance. That is called the base, acid and the base, to formation of the ammonium ions and the Cl minus ions according to the Bronsted or the Laurie-Bronsted concept, or it is also called as a Protonic concept. Now, see this example, repeat again, HCl plus NH3 that gives the ammonium and the Cl minus ions. Now, here the HCl is the acid, NH3 is the base, then formation of ammonium ions is the acid and Cl also base. Now, this is the reversible one. Now, HCl, here is the acid, then formation of ammonium is also acid. Then ammonia is the one base, and in formation chloride ions is also base. Now, in this reaction, the HCl and the Cl minus, that is called the conjugate acid base pair. Conjugate acid base pair. Now, here NH3 and NH4, this is also called as the conjugate acid base pair, because only that chemical species differ by the one proton is known as the conjugate acid base pair. Conjugate acid base pair means what? The pairs in or the difference between or difference in only protons, chemical species or difference of chemical species of one proton or differ by one proton is known as this conjugate acid base pair. Therefore, in this HCl and the Cl, that is one pair, only differ by one H, one hydrogen. Now here also the ammonium and the ammonium only differ by the hydrogen, only differ by the one hydrogen, or chemical species differ by the one hydrogen is known as the conjugate acid base pair. Therefore, HCl and the Cl is the one pair as conjugate acid base pair. Then NH3 and the ammonia, that is also the one conjugate acid base pair. Now HCl and that base one, here acid one and base one is the conjugate acid base pair. Ammonia base 2, here acid 2, this is also the conjugate acid base pair. Now this is about the Lowry-Brownsted concept, or also called as the Protonic concept. Now third one is the Lewis. That is also very important, and that Lewis theory is also same year, that is 1923. He proposed that theory, that is very important theory, that is also called as the electronic theory. Now electronic theory or Lewis concept about the acids and the bases. Now according to the Lewis, how can define that acid, how can identify the acid or explain that acid? Acid is a substance which can accept the lone pair of electron, lone pair of electron, that is called the acid. And base is nothing but the which can donate a lone pair of an electron. In short, here the accept the lone pair of electron, here donate the lone pair of electron is nothing but the acids and the bases. Now for example, now here there are the two reactions. Now first reaction, H plus and the ammonia, that gives this H, N, H, H, H. Now here this hydrogen is the one acid combines with that base, this is a base, and to formation of the coordination bond, means acid combines with that base to formation of coordinate bond. Now here H plus, which accept the lone pair, this is the lone pair, nitrogen, lone pair of electron which accept the lone pair of electron, and therefore this is H plus is the acid. Same to the BF3, boron trifluoride. Now here the BF3 which accept the one lone pair of electron, and that's why BF3 is the acid. Then the base NH3, it is the base that contains the lone pair of electron. Now base NH3, here also base NH3 that contains the lone pair of electron. That's why it which donate the one lone pair electron to the H plus, which donate the one lone pair of the BF3. Therefore NH3 in first example, NH3 in the second example, also the base, and H plus and BF3 is the acid. Now empiric nature of water. Water is a empiric because water can act as a acid as well as the base. Water is the empiric nature of substance. Now for example, here H2O, that is in liquid, combines with the NH3 to formation of ammonium ions and hydroxyl ion. Now these are the product. Then in the same water combines with the HCl, that gives the hydronium or the H plus or the hydronium ions and the Cl minus ions. Now that contain the two waters, or the first example water, second example water, combines with the one is the base, combines with the another with the acid. Water which can donate the one proton to the ammonia, formation of ammonium ions and the OH minus ions. Another example, same water which can accept the one proton from this HCl. That's why to formation of H3O plus and the Cl minus ions. In first example, water acts as a this acid because which can donate one proton to the another. In second, water which can accept the proton from the HCl to formation of that product. Therefore, in first example which can donate, in second example which can accept. Therefore, to donate a proton and to accept a proton, that is nothing but the empiric nature. Means water is a empiric nature of substance. These are the two examples. Water in first acid and water that is the base. Now this is about the empiric nature of this nature of water. Now in your annual exam, sometimes that one question will be asked. What type of question is asked? In this topic, define the acid and bases according to Lowry and Brown state. Important thing is that according to Lowry and Brown state, only the donate a proton, which can donate a proton, and a base which can accept a proton. That is an important word. Or sometimes to define the Lewis concept, asked in that annual exam, how can define the acid and base? Then here accept the lone pair of electron. Here is the donate lone pair of electron. Or sometimes that in annual exam to explain the empiric nature of water. In that empiric nature of water, first define the empiric nature. Empiric nature means what? Which acts as an acid, as it is which acts as a base. That behavior is known as the empiric nature. And write on the at least two example. Two example means what? That is water is the here acid in first example. And then second example, water is a base. Means acid here is the base to formation. Their base plus acid to formation. Therefore, water is a empiric nature which carries the 2 marks. That is a very important. In this acid and base, I think in this annual exam that define the acid and base which carries the 1 or 2 marks. Okay. Now this is about the acids and the bases. Now next lecture or the period will discuss about the new points. Okay students, 100 point. Okay, right.